The paper is for the session May-June 2021 and this is the first variant. Let's look at question number 1. Question number 1 says, a winch operates by means of a force applied to a rope by a rope. The winch is used to pull a load of mass 50 kg. Now this is where the information comes in. The mass is 50 kg up a line of greater slope of a plane. That means it's an inclined plane. So just highlight this thing, inclined at 60 degrees. And it says the winch pulls the load a distance of 5 meters up the plane at a constant speed. There is a constant resistance to motion of 100 Newton. So what is it asking? Find the work done by the winch. Now the concept is that this is a scenario in which we apply the concept of work energy principle. And what you were taught in the regular class, that is, this is case number 4 according to the way that I teach. That is work done by external force. It could be using a rope, it could be using an engine. That is change in kinetic plus change in potential plus work done against resistance. So work done by external force is what they are looking for. So work done by winch. Change in kinetic is 0. Why? Because there is no change in speed because of constant speed. Change in potential energy, that is the base level, the potential is 0 and the change is m, which is 50, g, that is 10, sine of 60 degrees into distance along the plane, which is 5. So that is the second part that is done. And what is the last thing? Work done against resistance. So work done against resistance is resistive force into distance of 5. So now you use your calculator and the answer that you get is work done by the winch. So it was a small question worth 3 marks. So this is about, let me label the thing also. This is about work and energy. That is what the question is all about. Question number 2. It says this is about connected particles and it's a simple pulley. And let's see how it goes. Two particles A and B have masses m and 0.1 respectively, where m is greater than 0.1. Why are they saying this? They are saying this because mg will go down, the mass m will go down and the mass b will go up because the left hand side is heavier. So I'm just trying to draw a straight line, a vertical line. So this is mg and this is 0.1 g and this is the tension. This is the tension. This particle is going down, this particle is going up. That is the normal scenario. And all the wordings are written over there as usual. The string passes over a fixed smooth pulley and the particles hang vertically below it, and before that it's a light and extensible string. Both particles are at a height of 0.9 meters above the ground. The system is released from rest. That means the initial velocity is 0 and the height is 0.9 meters and the tension in the string is 1.5 Newton. Acceleration is unknown and acceleration of the system, and the tension is 1.5 Newtons. Particle B does not reach the pulley. That means it is still existing as a system. Now the first thing that comes to your mind is that apply the F is equals to ma equation to each particle. So mg minus tension is equals to ma. Tension is known. tension minus 0.1 G is 0.1 A. If I add both of them, that is mg minus 0.1 G, that is m plus 0.1 A. Now we are looking for m and we are looking for the speed at which A reaches the ground. But first of all, we know the value of t. We know the value of t. So basically, this is equation 1, this is equation 2. From this equation, I can evaluate A. So 1.5 minus 0.1 into 10, that is equal to 0.1 into A. So that is the information that I have. So I can evaluate A. So 1.5 minus 1 is 0.5. 0.5 divided by 0.1 equals to A. Therefore, A comes out to be 5 meter per second square. Now, I can either plug it in the equation 1. So this is also acceptable. This is also acceptable. You will find the value of m. So therefore, m multiplied by 10 minus 0.1 into 10, this is m plus 0.1 multiplied by A, which is 5. So therefore, you have to open up the bracket. This is 5m plus 0.5 and this is 1.0 and this is 10m. So 10 minus 5, which is 5m, and this becomes 1.5, and therefore m comes out to be 1.5 divided by 5, that is 0.3 kg. So that's an exact answer that you get. The speed with which A reaches the ground, that is basic kinematics. So basically this thing from here is taken down over here. Acceleration is now found, and now acceleration is 5 meter per second square. So therefore use equation of motion, v square u square 2 into A into 0.9. So v square is equals to 9. Therefore v comes out to be 3 meters per second. So I have done this question. I have done the previous question. Over here, of course, calculator was needed. I did not evaluate it, but question number 2 was easily done without using a calculator. Question number 3. What is this question all about? So now this question looks like it's a question of momentum. And since momentum was added in the syllabus in February, March 2020. So since then, it's a constant question that comes on and on. 3 particles of masses such and such are at rest in a straight line. First of all, they are asking about particle P is projected towards Q. So particle P projected towards Q with a speed of 5 meter per second. After P and Q collide, P rebounds with a speed of 3 meter per second. Find the speed of Q immediately after the collision with P. So now let me draw 2 diagrams. This is the first one. Let me draw a circle, another circle, and the other particle, that is particle B, and this is particle B. And before collision, after collision, that is what the scenario is all about. So now this left hand side is before collision. So label it as much as you can. And this is after collision. And this is particle P. This is particle Q. Mass of particle P is 0.1 kg. And as such, let me just erase it. So just let me write underneath it 0.1 kg, 0.2 kg, 0.1 kg, 0.2 kg. Particle P is projected towards Q. So therefore, this is 5 meter per second and this one was at rest. And it rebounds. That means the direction of the velocity is reversed. So let this be v meter per second and this one, this is 1 meter per second. It rebounds with 1 meter per second and this thing Q, this velocity is unknown. Let me label this thing as v meter per second. So simple working. that is 0.1 into 5, 0.2 into 0. Therefore, 0.1 into 1, which is negative. Why? Because it has rebounded, the direction is reversed, and this is 0.2 multiplied by V. So this is 0.5, this is 0, and this comes on the other side, that is positive 0.1. This is 0.2 V. So therefore, it's a beautiful coincidence that this V also comes out to be 3 meter per second. The previous question, the answer was also 3 meter per second, and this time it's also 3 meter per second. Now it says Q now collides with R. So now the diagram is about Q and it's about R. So Q is drawn in red, Q is drawn in red, and R I have drawn it in green. So let me draw it circular. So this is R and this is R. So coming back to this is a Q, the reddish is Q, and this is Q, and this is R, and this is R, and the weights and the masses are 0.2 and 0.5. So this is 0.2 kg, 0.5 kg, 0.2 kg, 0.5 kg, and Q was moving with V. V is 3 meter per second. So this is 3 meter per second. This was at rest. Given there is no subsequent collision between P and Q, find the greatest possible value of V. So R begins to move with V. Our V was different. So this is R moving forward, because of course when it's given a push from the left, it will be moving forward. And find the greatest possible value of V. Now the question arises, what about Q? So now the value of Q after rebounding, because of this, there is no subsequent collision between P and Q. Now P rebounded with 1 meter per second. That means the maximum value that it can have is 1 meter per second and nothing more. It cannot exceed. So actually this should be lesser than or equal to 1. So let's just use 1 because we have to do the calculation. So we need to work with some value. That value is 1. So therefore the working is this: 0.2 into 3, 0.5 into 0, 0.2 negative 1, and this is 0.5 into V. So R begins to move with the speed of V. So now what is the greatest speed? This comes out to be 0.6, this comes out to be 0, this comes out to be negative 0.2, this comes out to be 0.5 V. So 0.6 plus 0.2, that is 0.8 divided by 0.5, that comes out to be V. So the maximum value that it can have is 1.6 meter per second. As such, you don't need to involve any inequality because that's the only value that you can work with. It cannot exceed 1, otherwise it would collide. So that is the working for question number 3 of momentum. Question number 4 seems like a straightforward question regarding kinematics with constant acceleration. So this is the constant acceleration one. It says there are two cyclists, Isabella and Maria, and they are having a race. They both travel along a straight road with constant acceleration. So this needs to be highlighted. Starting from rest at point A. So Isabella, so now I'm labeling it in purple and I'm going to label this thing in reddish. So Isabella is the red one, accelerates for 5 seconds. So therefore accelerates for 5 seconds at a constant rate. She then travels at the constant speed she has reached for 10 seconds. Before decelerating to rest at a constant rate, again everything is constant over a period of 5 seconds. So if I draw this thing, I can either do it using equations of motion or I can do it using graphs. So I'm always very much interested in graph. So I have drawn a grid. and I'll just copy and paste the grid on this side, but there is some issue with the pasting thing. So let me just label it again like this and something like this. So this left one is for Isabella. So this is for this person, and the other person is Maria, and that I'll label it in purple. So now it says acceleration, constant, and deceleration. So there should be one portion like this, other portion like this, and then the last portion is like this. So I don't know for how long it's accelerating. No, it says 5 seconds. So therefore this is 5. Another 10 seconds, this is 15. Another 5 seconds, this is 20. This is time, and this is velocity in meter per second. And let this value be, this is unknown, and this value is v. And then it says, given that in the first part, this acceleration is a meter per second square, and what else are they asking for? That is all about it. When we talk about the other person, Maria, she accelerates at a constant rate. So she accelerates at a constant rate. Now this time acceleration is not given. Reaching a speed of 5 meter per second in a distance of 27.5 meters. That means the graph would look like this. And then she maintains the speed for a period of 10 seconds before decelerating to rest at a constant rate over a period of 5 seconds. So the graph is same thing like this, except the labeling is not the same. Maybe it's similar, but it's not the same. So now this time, this value is 5. This area under graph, that is 27.5 meter, which is the distance. Let this velocity be w, and another 10 seconds for the constant. So this is 15. No, first of all, is this 5? Yeah. And then for a period of 10 seconds and then 5 seconds. So this is 5 and this is 10, and then again this is the same thing as 20. And this is time, and this is velocity. Now first of all, what does it say? Given that A is 1.1. So A is 1.1. Find which cyclist travels further. So it's for 5 marks. Basically, it's just calculation. First of all, what you can do is that you can find V. V over 5 is 1.1. Therefore, V is 5.5. An area of this trapezium, that is half sum of parallel sides. These two sides are parallel. That is 10 plus 20. Multiplied by the height, which is V, which is 5.5. So therefore this is 30 into 5.5 divided by 2. So let me grab my calculator. So therefore this is half multiplied by 30 multiplied by 5.5. So that comes out to be 82.5. So this is the person, that is Isabella. So this is 82.5 meters. That is the first thing. Okay, now the second part, that is, it says you have to calculate this distance again. So this times half into 5 into W is equals to 27.5. So let's evaluate W. So that is 2 times 27.5. That is 2 times 27.5. That comes out to be 55. 55 divided by 5. So therefore W comes out to be 11. Let me just double check. Maria, constant rate, reaching a speed of 5. Now I think I mixed up the things. This is reaching a speed of 5. So therefore this is 5 and this is t. So this is not 20. So that is the main thing. let's do the correction over here. This is 10 seconds and this is 5. I don't know what is the total value of time. I'll soon find out. So therefore 5 into t into this thing is this much. Therefore this value of t, not w, this comes out to be 11 seconds. Therefore this labeling is t plus 11, which is 16 seconds, and this labeling is 21 seconds. That is the new thing, because the value of t was unknown, the value of speed was given. Now if I want to find the area under graph, that is half sum of parallel sides, that is 10 plus 21 multiplied by height, which is 5. So therefore when I do this calculation, 10 plus 21, let me get it right, that is 31 multiplied by 0.5 multiplied by 5, this comes out to be 77.5. Maybe there's some mistake that I might have done. Let me just double check. This is 10 between 11 and 21. This is not 16, my bad. This is, let me get this straight. So this was 11. 11 plus 10 is 21. 21 plus 5, this is 26. So now I'm getting this thing corrected. So therefore this is 26. And let me get this thing correct again. So 36 into 0.5 into 5, this comes out to be 90 meters. So the time for Maria is 90 meters. The time for Isabella is 82.5. Let me double check one more thing, and that is Isabella accelerates for 5, constant speed for 10, and then another 5. So 5, 10, 5, that is 20. This is perfect. Maria accelerates at a constant rate, and this comes out to be 11. And then 11 plus 10 is 21, and 21 plus 5 is 26. So therefore half into 10 into 26 into 5, that is 90 meters. And this is v divided by 5 is 1.1 in this part. Find which cycles that is for later. V comes out to be 5.5. Half sum of parallel sides, this is 10 and this is 20, that is 30. So therefore 30 divided by 2 is 15, and let me double check, 15 into 5.5, that comes out to be 82.5. So now S of Isabella is 82.5 and Maria is 90. So therefore they are asking the separate distances. Who travels further? So Maria goes further. So that is for sure. So this is for Maria and this is for Isabella. Now it says find the value of A for which the two cyclists travel the same distance. Now what is the scenario in this case? If they are gonna travel the same distance, and which distance should we take? That is a question. So now total distance traveled by Isabella is 82.5, and this thing is this. And does it give any hint? They both travel along the straight road with constant acceleration starting from rest at point A, and they have not mentioned who travels, what is the ending point. So let the ending point be this value, which is 90 meters, because that's the further travel. And if I apply this concept, that is for the first one in which the value of A is there, so therefore half sum of parallel sides, that is half bracket 20 plus 10, that is sum of parallel sides, multiplied by a velocity value which is 5, that should equal to 90. Now in this scenario A is unknown, so therefore velocity is basically v divided by 5 equals to A. Therefore, V is equals to 5A. So V equals to 5A. So therefore, the calculation is 30 divided by 2 is 15. 15 into 5A, that is equals to 90. So 90 divided by 75. 90 divided by 75, this comes out to be 1.2. So A comes out to be 1.2 meters per second square. That is the value of A for which the two cyclists travels the same distance. And they're starting from the same point. They are both traveling along this line. Now it says a particle moving in a straight line. Now this is again kinematics, but this time the kinematics is that of variable acceleration. So this is kinematics and this is variable acceleration. And what I'll do is that one more thing. This is June 2021 variant 41. So let me go to the June paper and let me go to this particular examiner report and let me read this out. This is for probability and this is for mechanics. Wait a minute. This is the third variant, second variant and the first variant. Now this question was well answered by most candidates. It is necessary to find the distances traveled by the two cyclists. In case of Isabella, the first stage of her motion involved constant acceleration and everything is there. Her speed after 5 seconds was 5A. She traveled 10 seconds, traveling a further distance, and they are basically breaking it into the part. And in the first 5 seconds, due to the symmetry of the motion, Maria traveled 27.5, reached a speed of 5 meters per second. And this is what she have traveled. By adding each of these stages for each cyclist, it led to the total distance traveled by each of them. An alternative approach was to sketch the motion for each cyclist. So basically what we have done is that we went for the alternative approach. On a velocity time graph which enabled the distance traveled to be found by calculating the areas under each graph, many well presented and strong solutions were seen, and the main errors were being numerical rather than conceptual. Candidates generally found this question part to be challenging. It was necessary to express the distance traveled by Isabella in terms of the acceleration A. This could have been done either by adding the three stages together or by using a single expression for area of the velocity time graph. Once this is done, the expression is then equated to 90, which is the distance traveled by Maria, and the resulting equation can be solved for the required acceleration. Common errors was to use an incorrect approach for finding the distance traveled by Isabella. So basically, when they were asking this question, so the thing was that since Maria traveled more, so therefore they are expecting that the two cyclists should travel the same distance. So they are taking the bigger distance and then equating it with this part. Now let's move on to the next one. That is question number 5. It says a particle moves in a straight line from rest at a starting point A and comes to instantaneous rest at a point B. So basically when t is 0, v is 0, s is 0. This is for point A. And for point B, when t is something, we don't know what is that something, and velocity would be 0 at point B. The acceleration of the particle is given by such, find the value of t at point B, and exactly that is what they are looking for. So acceleration is 6t raised to power of half minus 2t. Velocity is integral of acceleration, and this becomes 6t raised to power of half plus 1, which is 3 over 2, divided by 3 over 2 minus 2t square over 2 plus a constant of integration c. First simplify this. This is 6, this is 2/3, this is 3 raised to power of t raised to power of 3 over 2 minus t square plus c. Plug in this, plug in this. So therefore, first simplify this. This is 3 ones are and this is 3 twos are. So therefore, when t is 0, v is 0, therefore c comes out to be 0. So therefore, velocity is 4 t raised to power of 3 over 2 minus t square. That is the expression for velocity. That is what you get. Now it says it comes to rest again. So now velocity equals to 0, 4 t root t minus t square, which is t into root t into root t. So I have just want to make sure that we don't evaluate this first thing. That is why I'm taking this much common out. I'll just do both the approaches. So basically, I'm going to take this thing common and I'm going to take this thing common. So t and root t, I'm more inclined towards surd form rather than indices, minus root t equals to 0, therefore t equals to 0, root t equals to 0, therefore t equals to 0, and 4 minus root t equals to 0, root t is equals to 4, therefore t is equals to 16. So the alternative approach, which I think most people would be taking, so the alt approach is that 4t 3 over 2 minus t square is equals to 0, t into 3 over 2 into 4 minus t into 3 over 2 into t power half is equals to 0, t raised to power of 3 over 2, 4 minus t raised to power of half is 0, therefore t raised to power of 3 over 2 is 0, therefore t is 0. 4 minus root t equals to 0, therefore t is 16. So these are two different ways of working it out. Basically, I broke it up into the surd form. Now find the value of t, and the value of t is found, that is 16. Now it says find the distance traveled from A to the point where the acceleration of the particle is again 0. So the acceleration equation is 6t half minus 2t. So that is 6t half minus 2t, and make it acceleration equals to 0 when acceleration equals to 0. Therefore, 6 square root of t minus 2 t square root of t equals to 0. So square root of t is taken common out. So therefore root t is taken common out. I can also take a constant common, but I'm not interested. This is 6 minus 2t root t equals to 0. Therefore, you need to find the value of t. So either indices or this method, so any which way is acceptable. So root t equals to 0, therefore t is 0. 6 minus 2t root t equals to 0. 3, this is t raised to power of 3 over 2 equals to 0. Therefore, actually it's not 0, it is 6 divided by 2, which is 3. So t is 3 raised to power of 2/3. And if I'm not mistaken, let me first double check. This is root t, and this is extra t is inserted there by mistake. So therefore this t is not there and this t is not there. So this t is not there, and this is what's going to happen. So 6 minus 2 root t is equals to 0, root t is equals to 3, therefore t comes out to be 9 seconds. So now what is the last part? The distance traveled to the point. So therefore the distance between the limits 0 and what is the upper limit? The upper limit is 9 because that is what you have calculated, and the velocity equation is 4t 1.5 minus t square. 4t 1.5 minus t square dt, that is 0 to 9. You have to integrate it first. So that is 4 t raised to power of 5 over 2 division by 5 over 2 minus t cube over 3 between the limits 0 and 9, and then you can evaluate this thing. Question number 6. This question could either be about equilibrium or it could be about resultant. Now the first part is 3 coplanar forces of magnitude are given. Given that the component of the resultant force in the x direction is 0, when they write this statement, in other words, what it means is that in x direction, the forces are in equilibrium. That is what they mean by this. So therefore, let's first resolve each force. So this 10 and alpha is this, and this one is this, and this purple one is this. So therefore, this is 10 cosine alpha. This is 25 cosine 60. This one is 20 cosine 30. And in the first part, first of all, I need to find the angle alpha, then only can I find the resultant. So 20 cosine 30 is equals to 10 cosine alpha plus 25 cosine 60. And you make the subject and you'll find the value of cosine alpha, and hence you will find the value of alpha. So this answer, after using the calculator, this comes out to be 61.2 degrees. That is the rounded off value, correct to 1 decimal place. If you need it for the next part, use the unrounded value. Hence find the magnitude of the resultant force. So now one force would be acting this way up, the blue component would be acting this way, and the orange component would be acting this way. So now if I write it, this one is 20 sine 30, and we will take it to be positive because it's up. And this is 10 sine alpha, this is also positive. And this orange one is down, that is 25 sine 60, and this is negative. So when we add this all up, we take care of the plus sign, we take care of the plus sign, we take care of the minus sign. So basically 2 plus and a minus will give me the magnitude of the resultant, which comes out to be 2.89 Newton. So that's how this question is attempted. But there is a second part. It says given instead that alpha is 45, find the magnitude and direction of the resultant of the forces. Now the diagram is drawn over here. So I'll write 10 cosine alpha plus 25 cosine 60, 10 cosine alpha plus 25 cosine 60, and I think the other one was 20 cosine 30. So this is 20 cosine 30. This is what we resolve in the x direction. This is like horizontal resolution. When we move the calculator, make sure it's in the right mode. This comes out to be 2.250 and 56, depends how much accuracy level that you're working for. So this is 2.251. I'll work with this. When we resolve it vertically, so therefore this would be 10 cosine alpha. Remember that alpha has been changed to 45 degrees. Alpha has been changed to 45 degrees, and this is not cosine, this is sine. So this is 10 sine 45, that's up, and 20 sine 30, that's also up. So therefore this is 20 sine 30, that's also up. And what else is down? 25 sine 60 is down. So now 25 sine 60 is down. When you evaluate, this answer is coming out to be negative 4.580. What it means is that instead of up, this is actually down and this is actually right. So when I draw this diagram, you have to draw a force like this and you have to draw a force like this. So therefore this one is 2.251 to the right, and this one is 4.580 downwards. That means the resultant should be somewhere here. So how can you evaluate the resultant? The resultant is evaluated using Pythagoras theorem 4.580 square 2.251 square under root, that will be the value of resultant. And then what you can do is that you can calculate this angle theta. So tangent of theta, the basic angle, that is vertical over horizontal, 4.580 divided by 2.251, and this comes out to be 63.8 degrees. So this comes out to be 63.8 degrees, correct to 1 decimal place. So therefore the resultant is 5.10 Newton. That is the angle. This is like the x-axis. So therefore the direction of the resultant, find the magnitude and direction. So magnitude is 5.10 and the direction is 63.8 degrees below the horizontal. So you don't have to write the x-axis. You can also write positive x-axis, and you can also write below the horizontal. So that is, and you are drawing this diagram. So everything is clear in this scenario. Now question number 7, the last question. What is question number 7 all about? Now question number 7, it says a slide in a playground. So let me label this thing. There is this blue portion like this, and then there is this orange portion like this. It says a slide in a playground descends at a constant angle of 30 degrees for 2.5 meter. It then has a horizontal section. So the blue is also the slide, the inclined is also the slide, the orange horizontal is also the slide. A child of mass 35 kg modeled as a particle P. So let me label it. So there is a child of mass 35 kg and we will call this child as a particle. Starts from rest, top of the slide, slides down, then continues along the horizontal until she comes to rest. So that means the child would be coming to rest, starting from here and then going down and then going down and resting over here. There is no instantaneous change in speed. That means when the sloping portion ends and the horizontal portion starts, there is no change in speed. The child experiences a resistive force on the horizontal section and the work done against resistance. So now the work done against resistance on the horizontal section of the slide is 250 joules per meter. Now the first part, it is given that the sloping section is smooth. So first of all, let me emphasize one more thing. This paragraph from here to here, not only it's valid for part A, both the parts, it's also valid for part B, both the parts. That is first thing. Now part A, it says the sloping section is smooth. Find the speed of the child when she reaches the bottom of the sloping section. So basically it's just the blue line that we are interested in. So just draw the blue line like this. And this is the top. This is the bottom. The potential energy at the bottom is always 0 because that is the base level. From this point you are measuring the height. The potential energy at the top is what? M and G and sine 30, and distance along the plane, that is 2.5 meter. The kinetic energy at the top is 0. The kinetic energy at the bottom is what you are looking for. That is why they're asking for the speed. That is half into 35 into v square. There is no work involved because it's smooth. There is no work done against resistance. So therefore, total energy at the top equals total energy at the bottom, and then you equate it and simplify. So this whole thing equals this whole thing. So therefore you will find the value of V and whatever the value comes out to be. That's one approach. The other approach is, there is an alternative approach. Let me write it over here because as long as it's simple, let me write it. The alternative approach is, that is mg sine theta minus nothing is mass into acceleration. So mm cancel, g is 10, sine 30 is 0.5 equals to acceleration. Acceleration comes out to be 5 meter per second square. And then they are asking for the velocity. So v square is u square plus 2 into a into 2.5. Therefore, v comes out to be 5 meter per second. So this was actually faster. So this is based upon the concept of principle of conservation of energy. That is what I've done in this part, and this is based upon kinematics. F is equals to ma and equation of motion. So both are acceptable because there is no external force involved, there is no engine involved, so therefore both are acceptable. As long as the acceleration is constant, F is equals to ma and equation of motion is acceptable. Find the distance the child travels along the horizontal section of the slide before coming to rest. So again, kinematics is possible. Again, energy is possible. So the horizontal section, I have labeled it in orange. So this is something like this. For this section, the energy becomes, the equation becomes, change in kinetic energy is work done against resistance. So change in kinetic energy is, it's starting from 5 meter per second. This is 5 meter per second. And it's coming to rest wherever it's stopping. So the change in kinetic is half into 35 into 5 square minus 0 square. And work done against resistance is how much? This is 250 per meter. So 250 multiplied by D, and D is what you are looking for. So that is the answer for this particular part. So that's the value of D. So that is straightforward for 2 marks. Now let's move on. Let's see the second part. Now it says it is given that it is given instead. Now whenever this statement is written, a lot of people, they forget what exactly are we talking about. So they are saying, the examiner is saying that it's no more smooth. It is given instead that the sloping section of the slide is rough. So there is this slide and there is this horizontal rough surface, and the child comes to rest on the slide 1.05 meter after she reaches the horizontal section. Find the coefficient of friction between the child and the sloping section of the slide. And this is for 6 marks. So what I'm doing right now is that do we have any idea what is the velocity over here? It won't be the same as before. So let this be v meter per second. Let this be 0 meter per second. Change in kinetic is again equal to work done against resistance. This time this is 250 multiplied with 1.05, and this is half into 35 into v square minus 0 square. So when I do this calculation, let me do the calculation, and v square comes out to be 15. Therefore, v is square root of 15. Leave it as it is. We'll see what to do with it later. Now, basically, we are working backwards. So now, at this point, which is the bottom, our kinetic energy at the bottom, that is half into 35 into v square, which is root 15 square. Potential energy at the bottom is 0. When we talk about the top, it started from rest, so kinetic energy is 0. Potential energy is mg sine 30 into distance along the plane, which is 2.5. But this time, since it's rough, there is also work done against friction, that is F max into the distance, which is 2.5. But what is F max? F max is mu r, and r is mg cosine theta on this plane multiplied by 2.5. So now let me simplify this. This is mu, this is 35, this is 10, this is cosine of 30 degrees multiplied by 2.5. So therefore, let me label all the relevant parts over here. So this part is relevant. Let me just take out a green marker. This much is this. And at the bottom, this is what you are getting. So it looks like this. And at the top, this is what you have. Something like this. So therefore, since the start, this is the start and this is the end. So therefore, the working is total energy at the start minus total energy at the end is work done against resistance. So let me write it, that the start is 35 into 10 into sine of 30 degrees multiplied by 2.5 minus half into 35 into root 15 square, and that is equals to F max. You can either calculate F max separately and then evaluate, and that's your choice. That's mu into 35 into 10 into cosine of 30 degrees multiplied by 2.5. So one thing that stands out common, that is this 35. So if you want to simplify your calculation, you can take common, get rid of it, divide, and then make mu the subject, and at the end you will find the value of mu. So that was a moderate kind of paper, and that is May-June 2021 variant 4.1. And see you in the next class.